Today we're going to be doing prime factorization. So the first thing we need to do is get these terms filled in. So a number that has exactly two factors, one in itself, is called a prime number. That means I cannot break it down any further than 1 times itself. Now every number will have 1 times itself. Only certain ones stay there. If they continue and you can find more factors, then it's called a composite number. So a composite number is anytime you go past that 1 times itself. If you find at least one factor other than 1 times itself, you have a composite number. So we need to talk about 0 and 1. These are neither prime nor composite. So in this blank, we're going to put neither. So it is neither considered prime nor composite. They're special things. So today we're going to take a prime number and a composite number, and we're going to deal with prime factorization. So this, guys, is important. Prime factorization is when a composite number is written as a product, that's an answer to a multiplication problem, of prime numbers. So we're going to do some stuff with that, and hopefully it'll make more sense as we go on. So here these directions say prime versus composite. Determine whether the following are prime, composite, or neither. So one of the ways you did this in elementary school is you drew a line and you did what y'all called the U-turn. When you did the U-turn, you would put a line and you would start the factors. 1 times 21, 2 times nothing because it's not even, 3 times 7, can't think of anything else, and so it comes around. And what that means is we have 1, 3, 7, and 21 as our factors. There's 4 factors of 21. So once we go past that 1, this, guys, is composite. So we need to go ahead and write that. So then we go to the next one. It's 0. Well, if you remember from the definitions, this one is neither or neither. So I'm going to write that up. So let's look at 43. Every number will have 1 times itself. Well, then we have to start thinking about the other numbers. And if you know your divisibility rules, this really helps you a lot here. But we're going to rationalize ourselves through it. We know that 2 will not go into it because of that number right there. It's not an even number. 3, I can do some mental math here. 3 will not go into it. 4 will not go into it because I know 4 times 10 is 40. 4 times 11 would be 44. 5, it doesn't end in 5 or 0, so that won't go into it. 6 times 7 is 42, so 6 times 8 would be too high. 7 times 6 is 42, so that won't work. 8 times 5 is 40. 8 times 6 would be 48, so that's between it. 9, if you know your hand trick on your 9, you know this isn't going to work. It would either be 45. And then 10, we know that's not going to work. So once we get to about right there, 10, 11, 12, we can kind of think we have it covered. So there is no other factor. So this, guys, is prime. But you really do have to stop and think about it. Here we have 45. So every one will start out with 1 times 45. 2 won't go into it because it is even. What about 3? If you did the math or know your facts, you know that 3 will go in there 15 times. You know that 4 won't be it because 4 times 10 would be 40, times 11 would be 44. 5 will go in there. It'll go in there 9 times. 6, again, just like we talked about on the previous problem. 7, nope, it would be 42 or 49 around it. 8 would be 40, or they're 48, and so then we're back to 9. So this number has 6 factors, and that is a composite number. So how is that going to help us today? Today our assignment is prime factorization. We haven't even gotten to prime factorization yet. But these are the directions you'll see. Generate an equivalent expression using prime factorization. So in plain English, it means write an equal problem using prime numbers. All right? So here are the 5 steps you need to follow. The first one is start out by pulling out prime numbers either using the factor tree or the L. I will be showing you both of them. Continue to factor until only prime numbers remain. Order the primes from least to greatest. Use exponents, that should be an S, when appropriate, and then box your answers. So these are the steps you need to keep in mind every time. So let's go to the next one. So I have the steps here. I'm going to push my screen up just a little bit. So in 5th grade, y'all tend to be taught the factor tree. And the factor tree is just a graphic organizer that you start branching out the root system, and you can pick any factors that you know would make 50. You don't want to pick one that will never help you. But say you do 5 times 10. Well, 5 is a prime number, so I go to 10. I break that down again into 2 times 5. Those are both prime. So then I order it from least to greatest, 2 times 5 times 5. Oops, sorry. And then I see that I can write this in exponential form. So I'm going to go one more time. I'm going to go 2 times 5 to the 2nd power. And there's my answer. So if I were to expand that out, if I were to expand this out and solve it out, I would get 50. So this is what's called the factor tree. And it's usually what teachers teach you. I kind of like this next method better. They both work. They both do the same. I just think there's less chance for mistakes. So you get to pick. So go ahead and do the notes this way so you can see. So you take the number and you do what's called an L. You put an L there. I'm going to take out a 2. Why am I taking out 2? Because I see it's even. So the first thing I'm going to do is take out a 2. And I'm going to divide this number by 2. So 36 divided by 2 would be 18. Then I'm going to do another L. I'm going to take out another 2. It's still even. 2 divided by 18 would be 9. Well, 9 is not even, but it's not prime. So I know that 3 times 3 equals 9. So I take out a 3 and I have a 3 remaining. Well, in this case, I have gotten all my primes. And what I like about it is you're not losing anything in here. Sometimes I would have kids, when I've used this, that would forget a branch or get confused. Everything's on the outside. So you would do the same thing, put them in order from least to greatest, 2 times 2 times 3 times 3. I'm going to look for those ones that are repeated multiplication, which are both of those. They're both repeated twice. So I have 2 to the 2nd power, or 2 squared, times 3 to the 2nd power, or 3 squared, and there's my answer. So it really is up to you. They do the same things. It's just, as a teacher, I've seen kids, they forget a branch of the roots of the tree, and I like this better because you can just start dividing out numbers. Usually your lowest primes are 2, 3, 5, 7, 11. Those are your lowest primes, and those help you get those out. So let's look at 8. We'll do this one factor tree. So we can do 4, and that would be 2. 2 is prime. By the way, 2 is the only even prime number. Did you know that? It is the only even prime number. Anything else that's even past this will be composite. I still need to break 4 down, so it'll be 2 times 2. And so here I write it down, least to greatest. Well, they're all the same number, but I need to notice that it's repeated 3 times. So I can write my answer as 2 to the third power, or 2 cubed. So for 81, I'm going to go ahead and do the L method. All right. So it is an even number. I cannot pull out a 2, but I look at that and I'm going to pull out a 3. If you don't know that 81 can be divided by 3, you need to do the math. But I'm going to look at my primes over here. My primes 2, 3, 5, 7. I know that 3 times 7 is 21. So those are the two, if it ends in 1, that I'm going to think about. 3 and 7. So when I pull out a 3, it will go in there 27 times. I can pull out another 3, I have 9. I can pull out another 3, I have 3 remaining. So there's nothing left, that's all primes, so I have 3 times 3 times 3 times 3. That 3 is repeated 4 times, so I have 3 to the 4th power. Okay, so I don't want to confuse you with the two different methods. I just want you to think all these are graphic organizers, so I can choose one that works for me. This would be the same thing you would have if you did it as a factor tree. It's just that I like keeping it in a row, and my last number down here is prime. I find this a little visually confusing, but this may totally work for you. There's more than one way to get to HEB. All right, kiddos, you do have some guided practice to do, and it'll be a self-check. Look at the next file.